Hello and welcome to Electromechanical Robotic Systems Midterm project. In this project, we had to design a circuit that would be um, representing a pinball circuit, for which we are using an Arduino board. We have a LCD screen, a joystick, a servo motor, photoresistor, two buttons, one for start, one for flipper, LED, and this is an addition. I am using a 7 segment display, uh, which is powered by a shift resistor. So these are all my components, and I also have a buzzer for creating the sound. So I'll just show how the project works. um, my LED says pinball is ready to start. So when I press start, I have 3, 2, 1 going on here, and the game starts. So now I when I um, press my joystick, which means the ball is hitting the joystick as a bumper, my score is increasing. And when I press my flipper, that's when the flipper works. So this is the flipper button, and I have a threshold for light, but in case the ball passes through it, then my number of balls reduce. So it reduced to 2. If I do it again, it will reduce to 1. And uh, it's still, my still game is going on because I have 3 number of balls. Again, I can keep increasing my score as much as I play. I have only connected it to the VRX because I had limited number of points. I'll just end the game by, yeah. So this is how the entire game works, and if I press start again, the game will start again. For now, I'm just gonna end it again. Now I'll explain how the circuit is connected. So I have the LED screen which has 16 points. So I'm not gonna explain each point, but I have digital point 2 to 5. I have pins that are connected to digital point 2 to 5, and 11 and 12. There are a few that go to ground and few that go to 5-volt connection, one that goes to the potentiometer. So that is the entire connection for the LCD display. Then I have my joystick, in which I have one pin that goes to A0, that is for VRX. Then I have a 5-volt connection, and then I have a ground connection. So that is how my joystick is connected. Then I have the servo. For my servo, um, I have one that goes to ground, one that goes to 5 volts, and one goes to D9. So that is how my servo is connected. Then I have the 2 flipper buttons. So I have one wire that goes to ground for start, and the second one goes to D7. And for the flipper, one goes to ground and the second one goes to D8. Uh, then I have the photoresistor, in which I have one end that goes to 5 volts, and the second end I have a 10k resistor that goes to ground, between which I have the analog read wire that goes to point A1. Um, then I have this buzzer, in which one point goes to ground and the second one goes to uh, D10, the digital pin number 10. That's how the buzzer is connected. And then this is the final addition to the entire circuit, which is my the 7 segment display, which is actually powered by or used is can be made used by the 74HC95, which is the shift register. So the 7 segment display is used to show 3 to 1 countdown before the game starts. Since the Arduino did not have the enough free digital pins to directly control all segments of the display, I use this shift register. The shift register takes the serial data from the Arduino using only 3 pins, the data, clock and latch, and it converts into multiple parallel outputs that drive the segments of the display. This allowed me to save the Arduino pins while still adding this countdown feature. So this is the one additional feature that I have. There are various like 7 segments that are A, B, C, D, E, F, G that are connected to this using 220 ohm resistors. One goes to 5 volts from it, and one goes to ground. A few go to ground. So that is how this entire connection is made. So this is my circuit connection completely explained. I actually had to write a few of them down because there were so many pins, and I'll just explain the problems that I faced while making this project. One was that my photoresistor was not working properly. I had different light conditions whenever I was making the circuit, because of which I had to change the threshold multiple times, which I got very good at. So I could do that. But after a point, the photoresistor just stopped responding, and I did not understand what was going wrong. So I thought it's some A0 pin that is interacting with A1. So I tried like a few like I tried troubleshooting it a lot of times. Finally, I found out that the wire that I was using uh, was faulty, because of which I finally replaced the wire. So it started working. So I used the serial monitor, the serial plotter a lot of times to actually figure out my thresholds and figure out or troubleshoot this problem. Um, the connection for the digital like the 7 segment display was one of the toughest, because I had to correlate and find out each pin on this and then on this, and then again like I had 220 ohm resistors in a very tight area to actually connect. So but it was fun. It was a fun experience adding this little feature. um, so yes, this is my midterm project submission. Um I have this code right over here.